Bem-vindo ao quarto evento da iniciativa AR. Estamos muito felizes por receber-vos aqui esta noite e esperamos que se divirtam. Good evening. I'm so excited to be here to welcome all of you to the Champalimaud Centre for the Unknown. My name is Claire, and I work in one of the laboratories here in the Champalimaud Neuroscience program, alongside our amazing group of speakers you will get to hear tonight. We are especially excited to have you all here during what is the final evening of the International Brain Awareness Week. Semana Internacional do Cérebro, which was spearheaded here in Portugal by the Sociedade Portuguesa de Neurociencias in collaboration with Ciencia Viva. We have the honor of having several members of the SPN with us in the audience this evening, and I would like to extend a special welcome to them to show our appreciation for the amazing work they did this week throughout the country to raise awareness about brain research. And in honor of the spirit of Brain Awareness Week, we are collecting donations for ARIA, the Asociação de Reabilitação e Integração da Ajuda, which is a non-profit organization here in Lisbon, whose mission is to provide resources for people with mental health disabilities. Since tonight we will be discussing myths about the brain, we want to show support for these individuals whose lives are dramatically affected by misconceptions about mental health disease in our society. After the event, there will be more information about the organization, and you will find jars where you can leave a donation if you feel inspired, or you can also purchase one of our new odd logo pins, and all of the proceeds will go to benefit ARIA. So, without further ado, I'd like to present tonight's event, How the Brain Got Its Wrinkles and Other Stories. We all seem to have a strong innate curiosity about what goes on in the world around us, including what's happening in our own minds. Sometimes in our drive or need for understanding, we create stories to try and help us explain or make sense of all the phenomena we encounter in our environment. As an example, 5,000 years ago in ancient Greece, a group of sailors discovered a skull they believed must belong to a one-eyed monster we now know of as Cyclops. I'm sure many of you have heard stories or read tales of these mythical creatures who terrified Europeans for generations and were thought to devour humans and serve evil gods. Well, as it turns out, these creatures really do exist, and you can find them still today roaming the African savanna or living here in Lisbon at the Jardim Zoológico. What these sailors had in fact discovered were elephant skulls, and they had simply mistaken the nasal cavity for the elephant's trunk for a single eye socket. I find this a nice example that illustrates how a myth might come to be. These people had almost all the right pieces of information in their hands, and they simply placed them in the wrong order, and then filled in the gaps with their imagination. The brain, to this day, remains one of the most perplexing mysteries of the natural world, and this lump of gray wrinkles has inspired an amazing amount of excitement, confusion, imagination, even awe. And perhaps most importantly, it has generated a burst of creativity in modern science and in modern scientific approaches that we use to study the brain. These are just a few examples of some of the techniques that we use in neuroscience to try and fill in the gaps. So, where do we even begin to untangle what is really true from what is just myth? Tonight, to try and show you how a neuroscientist might do this, we have 5 of our very own scientists from the Champalimaud Neuroscience program to speak to you. Rui Oliveira, Susana Lima, Megan Carey, Marta Moita, and Adam Kemp are here to include all of you in this quest to critically consider what we think we know and what still remains to be discovered about the brain and the mind. Each of them comes from a different background and has a different set of perspectives and ideas that drive their research. We hope that you will all go home tonight with a sense of the kinds of questions that fascinate us and a taste of how we or any of you could go about attempting to solve these complex problems. However, they won't be able to do this alone this evening, and they're going to need all of your help. So everyone who has a mobile phone or any kind of electronic device, please take it out and hold it up with the screen towards me. This will be your tool to vote on some questions about the brain that we're going to ask throughout this evening's talks. So I will quickly explain how this is going to work. First, the question will come up on the screen, and there will be two choices. The first answer will appear, and as soon as it shows up in white, you will have exactly 7 seconds to vote, so it's very quick. Then the next choice will appear, and you can vote. And then we will have a short clip where a student will give you a taster of what the right answer could be. So why don't we practice first with a real million-dollar question. So which is better, Benfica or Sporting? So you will get ready to vote. As soon as Benfica appears in white, those of you who vote Benfica will hold up your phones towards the screen.
Okay.
And everyone vote? Perfect. Okay, so those who vote for Sporting? And let's see the results. Okay, so it seems like you guys have the right idea, more or less. So let's get this show on the road with the first real question about the brain. Now, although the title of the event is How the Brain Got Its Wrinkles, this is actually a surprisingly difficult question to answer, and we ourselves would love to find out. So why don't we get started with a much simpler question. How many wrinkles does a brain have? You'll have two options. A is 30, B is 100. Those who vote 30, hold up your phones. Those who vote 100, hold up your phones. So, actually, this is a trick question. And now Anna will explain to you.
Not all brains have wrinkles, or more accurately, cells. The human brain has a lot, around 30 major cell size. A monkey brain still has quite a few, around 10. But if you were to look at a bird brain or a mouse brain, like this, you can see it's almost entirely smooth. The wrinkle part of the brain, which is the outer layer, is called the cortex, and it's a late evolutionary addition, only being found in mammalian brains. It's involved in a huge number of different processes, generally ones we think of as more complex, such as thought or attention, even generating a personality. Although the cortex has certain areas which seem to be more involved in some of these behaviors, the brain is amazingly adaptable. So we can never say for certain that one area or one sulcus is specifically for something. The human brain, with its amazingly advanced cognitive capacities, seems to have so many sulci because that allows more cortical matter to fit into a smaller space, a bit like crumpling up a ball of paper. This doesn't mean, though, that unwrinkled brains can't do amazing things. Some birds in the corvid family, for instance, this Caledonian crow, can remember the locations of over 15,000 nuts and seeds, which it hides during autumn so that it can retrieve them during winter. So next time you forget your car keys, remember our very intelligent, although unwrinkled, bird brain cousins.